Hey everyone, and welcome back to the channel. Today, we're talking about a mission that marks a true turning point in human history. For the first time in over 50 years, humanity is about to venture back into deep space, beyond the familiar confines of low Earth orbit. We're going back to the moon, and the mission leading the charge is called Artemis II. This isn't just another launch. Artemis II is the crucial next step in NASA's ambitious plan to establish a long-term human presence on the lunar surface and, eventually, to send astronauts to Mars. It is the mission that bridges the gap between the successful uncrewed flight of Artemis I and the future lunar landings we've all been dreaming of. It's a full-up stress test of the hardware, the software, and the human spirit. On board will be a crew of 4 trailblazers: Commander Reid Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. Together, they are about to embark on a journey that will take them farther from Earth than any human has ever been before. So strap in, because we're about to break down every phase of this incredible 10-day voyage. It all begins at the historic Launch Complex 390 at NASA's Kennedy Space Center in Florida. This is the same ground from which Apollo and Space Shuttle missions once soared. Standing tall on the pad will be the Space Launch System, or SLS. This isn't just any rocket. It is, quite simply, the most powerful rocket ever built by humanity. When its engines and solid rocket boosters ignite, they will generate over 8.8 million pounds of thrust, shaking the ground for miles around and pushing the Orion spacecraft skyward with incredible force. The ascent is a thunderous, G-force heavy ride that lasts just over 8 minutes. Once the boosters and core stage have done their job and separated, the Orion spacecraft, with its crew inside, will be in an initial elliptical orbit around Earth, but they won't be heading straight for the moon just yet. The first 24 hours of the mission are dedicated to a critical checkout phase. The crew will guide Orion into a high-altitude orbit, reaching a peak of thousands of miles above the Earth. This part of the mission is designed to rigorously test Orion's life support systems, its navigation, and its manual piloting capabilities. Think of it as a final dress rehearsal. It allows the crew and mission control to make sure every system is working perfectly while they are still close enough for a quick return to Earth if any serious problems arise. They'll test the hand controllers, verify the life support is scrubbing carbon dioxide correctly, and ensure they have full command of their new deep space vehicle. Only after every single check is complete and all systems are green will mission control give the final go for the next giant leap. With the go command given from Houston, it's time for the main event, the translunar injection or TLI burn. This is the moment that truly commits Artemis to its lunar journey. The interim cryogenic propulsion stage, which is the upper stage of the SLS rocket, will fire its powerful engine for a prolonged burn. This burn acts like a massive push, accelerating the Orion spacecraft from its Earth orbit and flinging it onto a precise 4-day trajectory toward the moon. From the crew's perspective, this will be an unforgettable experience. As they speed away, the Earth will shrink behind them, transforming from a vast horizon into a beautiful, fragile blue marble suspended in the blackness of space. For 4 days, they will travel across the 240,000-mile expanse that separates our world from its lunar companion. During this transit, the crew won't just be passengers. They'll be busy conducting tests, checking systems, and preparing for their lunar encounter. They will also be a vital part of a unique experiment, testing a laser-based communication system. This technology promises to send data, including high-definition video, back to Earth at much higher rates than traditional radio waves, which will be essential for future, more complex missions to the Moon and Mars. Now, here's where Artemis II differs significantly from the Apollo missions. Unlike Apollo, which fired engines to enter into a stable orbit around the Moon, Artemis II will perform what's known as a lunar flyby using a free return trajectory. Imagine tracing a giant figure 8 in space. The spacecraft will loop around the far side of the Moon, and the Moon's gravity will naturally bend its path and slingshot it back towards Earth. This is an elegant and efficient piece of orbital mechanics, as it doesn't require a major engine burn to begin the journey home, making it inherently safer. During this flyby, the crew of Artemis II will set a new record for the farthest distance a human has ever traveled from Earth. They will fly thousands of miles beyond the moon's far side, looking back to see the moon and the Earth in the same field of view sight witnessed by only the Apollo astronauts before them. From this incredible vantage point, they'll see the side of the moon that is permanently hidden from us, a cratered and ancient landscape. They'll also experience what's known as Earthrise, watching our planet appear from behind the lunar horizon. This moment, as described by past astronauts, is a profound, life-altering experience that underscores the beauty and fragility of our home planet. While in this deep space environment, they will continue to gather crucial data on the spacecraft's performance and the effects of deep space radiation on the human body. After looping the moon, the 4-day journey back to Earth begins. As Orion accelerates towards home, pulled by Earth's immense gravity, the crew will be preparing for the most dangerous phase of any space mission, reentry. Orion will slam into the top of Earth's atmosphere at a blistering speed of approximately 25,000 miles per hour, or about 40,000 kilometers per hour. That's more than 30 times the speed of sound. At this velocity, the friction with air molecules will generate immense heat, causing the spacecraft's heat shield to endure temperatures approaching 5,000 degrees Fahrenheit, almost half as hot as the surface of the sun. This is the ultimate test for Orion's heat shield, which is one of the most advanced ever designed. The crew inside will experience intense G-forces as the atmosphere rapidly slows them down. This fiery descent is followed by a precisely choreographed parachute sequence. First, a series of smaller drogue chutes will deploy to stabilize and slow the capsule. Then, the 3 massive main parachutes will unfurl, each one the size of a football field, to gently lower the Orion capsule for its final descent. The mission will conclude with a gentle splashdown in the Pacific Ocean, just off the coast of San Diego. Waiting nearby will be U.S. Navy recovery teams, ready to safely retrieve the crew and the spacecraft, bringing this historic 10-day journey to a successful end. So, when can you watch this historic event unfold? Mark your calendars. While space missions can have their schedules adjusted, NASA is targeting the launch on 6th of February 2026. You absolutely won't want to miss it. NASA will provide live, continuous coverage of the entire launch event. You can tune in on NASA TV, their official YouTube channel, and the NASA app. This is more than just a rocket launch. It's a testament to human ingenuity and our unyielding desire to explore. It's the moment a new generation gets to witness humanity's next giant leap. Thank you so much for watching. If you're as excited about the future of space exploration as I am, make sure to hit that subscribe button and turn on notifications so you don't miss any updates on Artemis and beyond. Let me know in the comments what you're most excited to see from the Artemis II mission. Until next time, keep looking up.